Hello everyone. In this video, I will be discussing to you circular functions. Let's have a review first about the unit circle. Let's say this is our circle placed in the rectangular coordinate system. A circle is a unit circle if the radius is equal to 1. That means if this is the origin or this is the center of the circle, moving towards any point on the circumference of the circle will actually give us a value of 1, or that is, the distance from the center of the circle to any point on the circumference is equal to 1. In this case, the point illustrated on the screen is actually 1, 0. Always remember that any point on the rectangular coordinate system is actually represented by an ordered pair. This point here is actually 0, 1, and this point is negative 1, 0. Lastly, we have this 0 and negative 1. Now let's assume a position of a terminal side, and notice that the terminal side will intersect a point on the circumference of the circle. But unlike these 4 points here a while ago, this point does not have a specific value of x and y. Okay, so it is very clear here in this first point, for example, that x is equal to 1 and y equals 0. But in this point, we do not exactly know the values of x and y. So we'll just label it as p, x, y. Okay, we can drop this point to the x-axis in order to get a value of x, and also we can also align the point to the y-axis to get the value of y. But again, we do not exactly know the specific values. There's only one thing that we are sure of, and that is the x value is less than 1, right? Because of course this is 1 here of the x-axis, so this is less than 1. Same way with y, this is 1 of the y-axis, so this is less than 1. Now, we can actually take this part here. Notice that this is only a y value, or that means this length here from the origin going to this position is actually a y length. This length is actually equivalent to these broken lines, and so I can also label that as y. Okay. We can assume a value of the angle this time as 30 degrees. Again, this is only an assumption. The angle theta can be any angle. This length here, or the distance from the center going to this point of intersection between the terminal side and the circle, is actually equal to 1. Because, again, the line segment is the radius of the circle. And just remove some of the things and try to focus in here. This line segment from the center or from the origin going to this position of the x-axis actually measures x. And so we have this right triangle. Okay, so this is a right triangle. Why am I sure this is a right triangle? It's because, of course, we drop this point vertically. We drop this point vertically to a horizontal line, which means they are already perpendicular to each other. So this is 90 degrees, and therefore we have this right triangle. Now you have to remember SOHCAHTOA, right? SOHCAHTOA, that sine equals opposite over hypotenuse and so on. Let's have sine first. Again, sine theta is equal to the opposite over hypotenuse. Our theta this time is 30 degrees. The opposite side is y, and the hypotenuse is actually 1. Okay? So, I substituted the values directly. Sine of 30 degrees is equal to the opposite, which is y, all over 1, which is the hypotenuse. Simplifying further, that gives you sine 30 degrees equals y. You may use your calculator to make sure that you are correct, and so y is equal to 1/2 actually. To find the value of x, you may use the cosine function. Again, from SOHCAHTOA, cosine theta is equal to the adjacent side all over the hypotenuse. So we have here cosine 30 degrees, which is our angle theta, equals the adjacent side, which is x, all over the hypotenuse, which is 1. Then we have cosine 30 degrees equals x. Okay, I only simplified x over 1. That's of course equal to x. So the value of x is equal to the square root of 3 all over 2. The ordered pair of the point is now square root of 3 all over 2 and 1/2. In general, x is just equal to the cosine of theta and y is equal to the sine of theta. While tangent is equal to y over x, because notice that in the triangle we have, this is theta here, the opposite side is y, and the adjacent side is x. So tangent theta is equal to y over x. Or that could be reduced into sine theta all over cosine theta. In short, if in dealing unit circle, all you have to do is to find the value of sine theta first, followed by cosine theta, or whichever you want. And then after that, once you have these values, you may substitute them into the formula tangent theta equals sine theta all over cosine theta. Now you may continue doing this in order to find the values of the x coordinate and the y coordinate, regardless of the value of theta. Let's say, for example, if we take this point and let's say that point is the intersection of the terminal side and the circle, given the angle theta and standard position is 45 degrees, because this is the usual example in the unit circle. So let's say this is 45 degrees now, and remember that the values of x and y are square root of 2 all over 2 and square root of 2 all over 2. If you want to know where did we get these values, you may just do the same as what we have done earlier. That is, substituting 45 degrees here, you may use your calculator. Cosine 45 degrees is just equal to the square root of 2 all over 2, and sine 45 degrees is also square root of 2 all over 2. So basically, all you have to do is to substitute the value of theta to these two equations here in order for you to find the coordinates of the point. Another one, the very common example, is when the angle is 60 degrees. If that happens, that is actually 1/2 and the square root of 3 all over 2. Again, in the same way, if you want to know the solution, then all you have to do is to substitute 60 degrees to cosine theta and 60 degrees to sine theta. Okay? Or let me clarify it. All you have to do is to substitute the value only to theta. Okay, so that is cosine 60 degrees in your calculator and sine 60 degrees in your calculator as well. It will give you the values 1/2 and square root of 3 all over 2. Again guys, let me remind you that these formulas are only applicable to unit circles. Now let's proceed to general circles. That means all circles with any value of r or any radius. What will be the difference this time? So let's say we have this rectangular coordinate system and we have this origin, of course. Then let's have this terminal side. Now we don't know the value of r, so the point of intersection can be this one if the circle is smaller, or can be this one if the circle is bigger, or could be this or this or this one. Okay, so again, since we do not know exactly how big the circle is, then that means we do not know the value of r. Okay, because this one is general circles. Unlike a while ago, we were talking about the unit circle. So the radius is very specific to just equal to 1. In here, radius can be any number. So what do we do? The same way, we have this point x and y because we do not know the values of x and y. If we drop the point, we have this position in the x-axis, and this is the x coordinate. Again, we do not know the exact value for this one. In this case, it can be more than 1. Okay? It can be more than 1 or it could be less than 1 as well, since this talks about all circles, not just unit circles. Then we have this value of y as well in the y-axis. And this length here from the origin going to that point on the position of the x will be x units. Okay, so we don't exactly know what is the length of that line segment. We know that it depends on the value of x. Okay, so I'll just push it there. Then we have this value of y as well, but again we do not know that value, so we can just consider the variable y to represent that line segment. So the broken lines also will be equivalent to y. So in the same way a while ago in the unit circle, this part here, this line segment is just the same with these broken lines here. Now we can proceed. We have this angle theta also, right? That angle theta is actually in standard position. Okay, I'm gonna label it that way. Now, this is the circle for this scenario. Okay, so just for this scenario. And that means we have that radius from the origin going to that point P. Again, it is not specific to one because this time we are not just limited to unit circle, but to all kinds of circles. Okay, so I'll just put R in there. It represents any number. I can just take this elements out and let's try to focus on the triangle. Let's see what happens. Okay, so that's the angle theta. Then we have this point P, and then we have this origin, right? Okay, so let's have this R, and then this point is the position on the x-axis, and that's x side of the triangle. Remember SOHCAHTOA again, guys. So sine is equal to the opposite over hypotenuse, or the sine theta is opposite over hypotenuse. We have cosine, and then tangent. Then sine is equal to y over r, therefore. Okay? I hope you understand this part. Okay? Sine theta. So theta is here, opposite side is y, hypotenuse is r. So I only substituted the values based on the triangle we have here. Again, I am allowed to use SOHCAHTOA because I am dealing with a right triangle. Though I don't have the symbol here, but I am sure this is 90 degrees because I dropped the point to the horizontal line. Okay? Dropping the point means vertical. And then we have this one. We have this horizontal, so it forms 90 degrees because they are already perpendicular. Now cosine is x over r. Notice that this is theta, and so adjacent side is x, and r is our hypotenuse also. Then the tangent is equal to y over x because again, we have this opposite side y all over x, which is our adjacent side. So basically, if we are dealing with a unit circle, all you have to do is to substitute 1 here in the radius or in r. If you can remember a while ago, we had sine of 30 degrees equals 1 y over 1 because that was a unit circle. But in this case, since we are not dealing with just unit circle, okay, because we are dealing with all types of circles, we are now using the variable r instead of having the value of r which was equal to 1 a while ago. From these three trigonometric ratios, we can now find the reciprocal functions. Okay, so we have the cosecant of theta, which is equal to r over y, the reciprocal of sine theta. We have the secant of theta, which is equal to r over x, the reciprocal of cosine, and the cotangent of theta, which is equal to x over y, that is the reciprocal of tangent theta. Let's take this example. Find the exact values of the 6 trigonometric functions if the terminal side of angle theta in standard position passes through 3, -6. We will now apply the trigonometric ratios above and find the values of the 6 trigonometric functions. We can illustrate first. We have this rectangular coordinate system, and so the terminal side is in quadrant 4. Okay, it passes through 3 and -6, as in this one. If this is 3 on the x-axis and this is -6 on the y-axis, then this is the point of intersection. So this point here, this point on the screen here on the terminal side is actually the intersection between the terminal side and the circle. So this is part of the circumference. Okay, that's 3, negative 6 anyway. Of course, we can extract the values. We have x equals 3 and y equals negative 6. I only took the coordinates. And then what's lacking here is the value of r. We don't actually have this value. But again, as I said, since this is a point on the circumference of the circle and this is the origin, this is the center of the circle, then therefore, that is the radius of the circle. And again, let me emphasize that this circle has a center at the origin. Okay? The center of the circle is at the origin. That means h and k are 0, 0. If you can still remember the equation of the circle in conic sections apex, we have x squared plus y squared equals r squared as the equation of the circle with center at 0, 0. Now, all you have to do is to substitute the value of x and y in order to get the value of r. So that's 3 squared plus the negative 6 quantity squared equals r squared. Or that should be 9 plus 36 equals r squared. That's 45 equals r squared. And so taking square roots on both sides will give you 3 squared of 5 as the value of r. Actually, positive and negative, but then again, radius is always positive. Okay, because that's a distance or that's a length, so it's never negative. Now, applying the ratios of the trigonometric functions above, all you have to do is to substitute the values. So since y equals negative 6 and r equals 3 squared root of 5, then you can just have this one. Okay, so y is negative 6 and r is 3 square root of 5. And then rationalizing, you will get negative 2 square root of 5 all over 5. If you want to make sure, you can just use your calculator. Then, for you to solve the rest of the values faster, you can just take the reciprocal directly. That means cosecant of theta is equal to 3 square root of 5 all over negative 6. So do not take the final answer anyway because this is already rationalized. Just get this one here. Okay, so that you will find the solution easier instead, because if you will get this final answer and do the reciprocal, you will rationalize it again. So be wise, just take this part here and then just reciprocate. So you have 3 square root of 5 on top and the negative 6 below, or 3 square root of 5 in the numerator, negative 6 in the denominator. Now simplifying further, that should be the square root of 5 all over 2. I only reduced, okay, the values 3 or the value 3 over 6 because that's 1/2. So we have here square root of 5, 1 square root of 5 all over 2, or the square root of 5 in here. Then for the cosine, that's x over r. That means you will have 3 over the 3 square root of 5. Okay, that's just actually square root of 5 all over 5. Again, the same way, if you want to use your calculator, it's really fine. Then, for the secant function, you have to do the reciprocal here. We'll just consider the reciprocal. So do not again use the final answer because it will give you an answer whose denominator is a rational expression, so you will need to rationalize again. Instead, just take this part here, do the reciprocal, so that becomes 3 square root of 5 all over 3. You may cancel 3 or divide 3 over 3, that's 1. So you will have a final answer of secant function, which is equal to the square root of 5. Then for tangent, you have y over x. So that's easy. That's just negative 6 all over 3. And so you have negative 2 as your final answer, or the value of tangent theta. And then you will have a tangent theta, which is equal to 3 over negative 6. When you reduce it, that's actually negative 1/2. So that's it. Those are the values of the 6 trigonometric functions. And anyway, this illustration is not really necessary. Just in case you will forget, then you may use illustrations to analyze and then find ways to find the values. Just remember this part. X squared plus y squared equals r squared. If you're good in analytic geometry, the circles, then it's not really hard for you to remember that when the center of the circle is at 0, 0, the equation is x squared plus y squared equals r squared. Okay? And then, in this part of the reciprocal functions, it's really up to you on where you are comfortable to in solving. In my part, I did the reciprocal in here, and this in here also and here because there are rational expressions, and when it happens, it's really best when you do it there instead of doing the reciprocals in the final answer. But in times that you will be solving, then it's really up to you on what you will do. Okay, just consider your comfort zone. In the last part, we are to find the value of the angle. Okay, find the value of the angle in standard position this time. Again, the value of the angle in standard position. So what do we do? In this part, you have to remember the definition of angle theta in standard position. Of course, if this is the illustration, you should know that this green angle is the angle in standard position. It starts from the right side of the x-axis, rotating counterclockwise towards the terminal side. In here, I am using theta as the symbol representing the angle. In this part, people, you have to consider the positive value. Okay, again, you have to consider the positive value. So, what is the use of the positive value? If you will be using the positive value, it will give you the reference angle. Okay, again, using the positive value, it will give you the reference angle. So what does it mean? Let's try to go back in the previous slide. So in this part here, notice that there's only one function that is positive among sine, cosine, and tangent. Okay, just forget about the reciprocal functions if we are only to find the value of the angle in standard position. So among sine, cosine, and tangent, one function is actually positive, and this time that's the cosine function. Okay, this is the cosine function. This is positive because this one is negative, this one is also negative. Now, using this positive value, you will be able to get the reference angle. Again, let me repeat, you will be able to get the reference angle, not the angle in standard position. But once you get the reference angle, you will be able to get the angle in standard position after that. Okay, I hope you can actually imagine the plan of doing the solution. So here, again, I'm doing it again here. The reference angle is the first thing that we will get. So using the cosine function, which is equivalent to square root of 5 all over 5. Again, I'm choosing cosine, not sine, not tangent. It's because cosine is the only positive function. And then, as I said, the positive function will give you the reference angle. So I am changing theta this time into r, so the reference angle. Now using the inverse function, that becomes r equals the inverse of cosine square root of 5 all over 5. You may use your calculator and get 63.43 degrees approximately as the value of the reference angle. Now, since our goal is to find the angle in standard position, you can just consider the formula in finding the reference angle in quadrant 4. Okay? So remember that in quadrant 4, the reference angle is equal to 360 degrees minus theta. This is coming from the previous discussion, right? 360 degrees minus the angle theta. That is how you get the reference angle in the fourth quadrant. In here, you will substitute the value of r. Okay, so you have now, from r, you have 63.43 degrees equals 360 degrees equals the angle theta minus the angle theta. By then, algebraically, you will get 360 degrees minus 63.43 degrees, or okay, that's the situation now. Since we subtracted, so I removed I already removed the reference angle in the illustration. You will now get the angle theta approximately 297.57 degrees. I consider approximate value since the value of r is already approximated. So when I substituted 63.43, then I already know that the answer is an approximate since this value is also an approximate. So we have here the angle theta, approximately 296.57 degrees. Now, there are cases when only the angle in standard position is being asked. Okay? And for you to solve it faster, I can actually give you some techniques in solving it. We are actually using this abbreviation ASTC. That's all for A, and then S for sine, and then T for tangent, and then C for cosine. So we have A for all. That means all functions are positive in quadrant 1. And then we have S, that means only the sine function is positive in quadrant 2. We have T, that means only the tangent function is positive in quadrant 3. And we have C, that means only the cosine function is positive in quadrant 4. So how do we use this concept? As I said a while ago, if you want to get the angle theta in standard position, first you have to get the reference angle. And where do we get the reference angle? We get the reference angle by applying inverse functions using the positive value. So let's say, for example, okay, given some values of the trigonometric functions, find the quadrant of which the terminal side is lying first, and then solve for the angle in standard position. Okay, so number 1, we have sine theta is equal to 4 over 5, and the tangent theta is equal to 4 over 3. Okay, I have to emphasize this anyway. It will not happen that there are two functions, that there are two positive functions while the other is negative. Okay, so we have three main functions anyway: sine, cosine, and tangent. We can actually set aside the reciprocal functions this time, since our goal is only to find the angle in standard position, and we do not care about the other values like the cosine, the secant, the cosecant, and the cotangent. So our goal first is to find the position of the terminal side, and in this case the terminal side is actually in quadrant 1. Okay, again, because there's no possibility that two functions are positive while the other function or while the third function is negative. Okay, so in this case, since sine function and tangent function are already positive, so we expect that the cosine function is already positive as well. So that means all functions are positive in this case. And since all functions are positive, that means the terminal side is in quadrant 1. Okay? So you can actually choose any of the function. You can use sine function or tangent function, and I tell you, when you do the inverse, it will give you the same answer. So for this one, I choose sine function, and that is actually 4 over 5, and r is equal to the inverse of sine, which is 4 over 5. Okay? R therefore is approximately 53.13 degrees. Again, this is still the reference angle. Our goal is the standard position. So since this is quadrant 1, R is just equal to the angle in standard position, theta. Therefore, our theta is just approximately 53.13 degrees. So no sweat. Okay, that's it. Let's have another example here. Sine theta is equal to negative 4 over 5, while tangent theta is equal to 4 over 3. Okay, so one is negative and then the other one is positive. So since one is negative and the other one is positive, we expect that the other is negative as well. Because again, as I said, there's no possibility that two functions are positive while the other function is negative, or while the third function is negative. Okay, so in this case, we expect that cosine is also negative. Tangent is positive here. So as I said, use the positive value. And in this case, the terminal side is actually in quadrant 3. How did I know? That's based on ASTC. So that's how ASTC helps. So it helps you determine the position of the terminal side. So in this case, the terminal side is in quadrant 3. Using tangent R, or tangent function, you have tangent r equals 4 over 3. So the reference angle is tangent or inverse of the tangent 4 over 3. That means you will get the same 53.13 degrees. So this is really important, right? It's really important for you to know the position of the terminal side, because without it, you will have the same answers in this case, but you have different scenarios. Okay? So notice that in this case, you have positive 4 over 5. In this case, you have negative 4 over 5. Then you might be asking, how did I come up with the same answers? Okay? So it's really important for you to know the position of the terminal side, because it's where you get the correct answer. So since r is equal to theta minus 180 degrees. Why? Because this is in quadrant 3. Remember the lesson in reference angles. So since the reference angle is equal to theta minus 180 degrees, if it's in quadrant 3, then we have to use that formula and substitute the value of r, 53.13 degrees. This time approximately theta minus 180 degrees. I'm already using the approximate value here because this value of 53.13 degrees is only an approximate. So by then, you have 53.13 degrees plus 180 degrees is the approximate value of theta, and you have 233.13 degrees as the approximate value of theta. So that's the angle in standard position. Let's make it formal. So theta is approximately 233.13 degrees. Let's have the last example. We have the cosine theta, which is equal to negative 3 over 5, while the sine of theta is equal to 4 over 5. So in this case, sine theta is positive. So using ASTC, I already know that this is in quadrant 2. So the terminal side is in quadrant 2, sine r is equal to 4 over 5. Okay, and then always use the positive value. Okay. In number 1, if you will try to use tangent, you will get the same answer, I tell you. And then you have sine over, let's continue anyway in number 3. So r is equal to the inverse of sine, 4 over 5. And then you have r is approximately 53.13 degrees as well. Okay, so I just changed the signs from positive to negative for you to see the difference. Okay, so this one is happening in quadrant 1, this one is happening in quadrant 3, this one is happening in quadrant 2. So notice that we get the same reference angles, but of course the angle in standard position will be different because we are dealing with different positions of the terminal side. Always remember that. So the position of the terminal side will really matter. And then we have since r equals 180 degrees minus theta, no? So this is r equals 180 degrees minus theta because we are in quadrant 2. And then you have 53.13 degrees is approximately 180 degrees minus theta. And so you have algebraically 53.13 degrees minus 180 degrees is equal to the negative value of theta. And so you have negative 126.87 degrees equals negative theta, multiplying the whole equation by negative 1, okay, to make theta positive. So you have angle theta is approximately 126.87 degrees. So again, it's important for you to know the positive value if you are only to find the standard position or the angle in standard position rather. However, if there's a need for you to find the values or the 6 values of the trigonometric functions, then there's no need for you to identify the or to use ASTC, since you can actually see already in the values. Just always remember to take the positive value and then take note as well that the positive value will not give you directly the angle in standard position, but the reference angle. So that's it for circular functions. See you next time.